Okay, thank you. Thank you. Carry on. Okay. Oh, sorry. Okay, those first two are fine. 9 X's at the top, 3 at the bottom, so there are 6 more at the top than at the bottom. So that is actually X's over 1, right? If we don't write that over 1. Okay, so 2, you say 6 divided by 3 is 2. A and A, those ones can cancel out. There is a B at the top that we don't have at the bottom, so that one can't cancel out. And then we have 2 C's at the top, 1 at the bottom. So we're left with a C at the top as well. Everything at the bottom is 1. Okay, this is 2 and C at the top. There is the next one. I've always said that I made a mistake from it. Then equals 3, I'll find that one. 3 C to the 4. 6 divided by 2 is 3. The B's cancel out. Let me just show that actually. Right, so the B's cancel out. 6 divided by 2 is 3, right? And then we have 6 C's at the top, 2 at the bottom, so we have 4 C's at the top. All right, and once you've gotten rid of those 2 C's at the bottom, there's nothing left at the top. Okay, next one, 13.4. 12 divided by 3 is 4. Where do I have more X's, guys, at the top or the bottom? Top, right? There are 6 more at the top, so that's X to the 6, that's left. At the top, I also have more Y's. 6 Y's at the top, 3 at the bottom, so that's 3 more at the top, so Y at the top 3. Now 13.5, guys, it's fine if you have like an in-between step where you wrote it as a fraction. Okay, that's probably easier to look at it in fraction form. Maybe I should just add that quickly on the side. So this is 2x cubed y squared z squared over. No, sorry. I'm looking at the wrong one. 13.5 I'm talking about. My apologies. Hello. It's exponent, not the numbers. The numbers are divided like we're doing. Yeah, just the exponent. All right, 12x cubed y squared z to the 4 over 3xyz to the 3. How did you do that? If you add that in, okay, 12 divided by 3 is 4, right? 3 x's at the top, 1 at the bottom, so we're left with 2 at the top. 2 y's at the top, 1 at the bottom, so there's 1 more at the top, and then for the z's, it's the same thing, right? 4 z's at the top, 3 at the bottom, so there's 1 more at the top. Okay, 13.6 was just a multiplication one, so then you multiply the numbers like you normally would. You say 2 times 3 is 6. There are 3 x's and another x, that's 4 altogether. Then we have 2 y's and 2 y's, that's 4 as well. 2 z's and 2 z's, that's also 4 again. Again, 4. Now for 13.7, guys, we did discuss it a long time ago, but not recently, so you might have forgotten. When you are having to decide whether multiplying or doing the exponent first, you have to do the exponent first. You can see it as simplifying the bracket, essentially, right? And Brodmann says brackets first. So you first have to do the squared. Okay, so you're going to say, what is 3 squared? 9, hey? 3 squared is 9. You could have had an extra step where you just wrote 3 squared first. That's perfectly fine. And then we learned yesterday when we have an exponent inside a bracket and outside a bracket, we are going to times those together. Sorry, let me zoom in a bit. So those are 2's, right? 2 times 2, that gives you an answer of 4. So now basically you have 2x times 9x to the 4. And now we know how to times numbers. 2 times 9 is 18. And if we have 1x and 4x, that is 5x altogether. Right, thank you. So 18x to the 5 is the answer there. For the next one, you don't have to put in this English step. We see we have ABC and CAB and CBA. Right? They're trying to make it look like they're not like terms, but they are all like terms, right? They have the same 3 letters. ABC, this 4 CBA, you can rewrite as 4 ABC. Just put them in alphabetical order. And negative CBA, you can rewrite as negative ABC. Okay, again, just alphabetical order. And that's ABC plus 4 ABC is 5 ABC, right? Minus ABC is again 4 ABC. Okay, so the final answer there is 4 ABC. And look at the next one, so now. A negative times a negative is a positive, do we agree? Right, negative times a negative is a positive. And then you have a 4 that you need to put in your answer. And you have x squared times x. So that will give you x cubed. Okay, so the answer for 13.9 is 4x cubed. Now in 13.10, we had to look at the whole negative and exponent thing that we looked at yesterday. And guys, like I said yesterday, it's fine also to write them out and actually do the multiplication. That's perfectly fine. Okay, so 3 times negative x cubed. Now what we say yesterday, a negative number or a negative variable to the power or that has an odd exponent. Agree that 3 is an odd number. Right? A negative expression here with an odd exponent is negative. But now that's still an x cubed, right? Right? So yes, it does become negative, but you also have to do the x. The x must also be cubed. Right? Yesterday, I think we did negative 2 to the power of 3. So we got to a negative answer, but we still had to do 2 to the 3. Right? So it's becoming a negative answer, but we also have to actually cube what is in that bracket. Okay, you can look at it as this is x to the 1. Sorry, this is x to the 1. And what's 1 times 3? 3. Okay, at the bottom, this. The 6 has nothing to do with that line. The 6 is on its own. You first have to do the exponents before you multiply. Okay, so that's what we said in, which question was that? In 13.7. Right, so just try to remember that. So you first have to do the exponent before you multiply. So here now we have a negative to an even exponent. What happens to that? That always becomes positive. You guys remember we wrote that down yesterday. So this is going to become positive x squared. But guys, if you forget that, it's fine. You can put in an extra step where you say 3 and then a negative x and then a negative x and a negative x like this. I saw that some of you used expansions in the class test and then you got it right. So that's fine. 6 and negative x and negative x. You could have done it like that. Okay? And then from here, there's actually a lot that you can do. You can even cancel out if you wanted to, right? But yeah, that's not what I would have done. But it's fine, you can do it like this if you want to. You can even cancel out now if you're looking at the expansion, or you can do the actual multiplication. You can say, what is a negative times a negative? Times another negative, right? And x times x times x is x. Okay, so it's up to you which method you want to use that, as long as your answer is negative x over 3. Okay, if you get that answer, it's fine, it doesn't matter. It's not wrong, but it's just not simplified. It's not simplified. So you can't leave a minus at the top or the bottom. It always has. Okay, any other questions on question 13, right? We looked at everything as an off. We start to mark 16. Right? This was very loud. Okay, 16.1. There we go. That was a multiplication question. then we know we can't make our exponents. Okay, it was 9x squared y to the 3 times 2x squared. But numbers, remember, you treat them like you always have. Okay, if I ask you at the beginning of the year what's 9 times 2, you would tell me it's 18. All right, we're still doing that. 9 times 2 is 18. 2 x's and another x, that's 3. Now we have 3 y's and 2 y's, that's 5 of them. So that's y to the 5. Okay, 16.2. I'll find that first one. Yes. Yes, I'll fix that now. Okay, 16.2. Guys, I will take you 4, and then that's going to be a 2 in the answer. What I do want to just say first, before I fix that, just add to this. Simplify the fraction first. So simplify fraction before calculating the root. I'm going to talk about that a bit more just now. I'll just also fix my mistake. Here we go. Thank you. Alright, if you have to find the square root of this fraction, right? And you look at all the things that you have in the fraction, none of those actually have square roots. I don't know if you noticed that. The square root of 20, what's that? Does 20 have a square root? No. Alright? If you look at the number at the bottom here, does 5 have a square root? No. What about x to the 3? Remember, what did I tell you yesterday? What number do we have on the outside here? If it's a square root, that's a 2, right? And when we're working with variables to get the square roots, we're going to say the exponent inside the root divided by the number outside. So that's going to give us 3 over 2, right? Which is not nice. I mean, it's okay, but we usually don't work with fractions as exponents. So none of these things actually, guys, will give you a nice answer if you try and find the root of it. But if you simplify it first, that makes it much easier. Do we agree with that 20 over 5 is 4? Right, 5 goes into itself once and into 24 times. Okay, that's why the 4 is at the top over here. Now we're looking at the x's. Where do I have more x's, at the top or the bottom? At the bottom, right? 2 more than at the top. That's why I have an x squared at the bottom. Okay, and if we're looking at the y, where do I have more? At the top, right? 4 more. So that's why that should be a y to the 4 in your square root. So guys, it's easy to find the square roots of all 3 of these things that we have now, the 4 and the y's and the x's. What is the square root of 4? 2. The square root of y to the 4, how I did that is I said y to the 4 divided by 2. Exponent inside the root divided by the number in front, right? So that's 4 divided by the 2 here. That's how I got y squared. And for this one, for the x, the exponent inside the root is 2. So we divide that by the number in front, which is a 2 as well. Okay, but you don't have to show that, like I said in class yesterday. You can just kind of do that in your head. That's everything. Yeah, we find that one. So guys, if they ask you to find the square root or whatever of numbers and stuff that don't have, then you definitely have to first simplify what you have in your root. Okay, we'll usually work out like that. All right, the next one is just a multiplication question. They wrote it using dots though. Have we seen that notation before, where they use a dot instead of a time symbol? Yes. Okay, so I couldn't remember if we actually seen that. All right, so guys, just a reminder, those of you that might have forgotten, if they just use a dot in between 2 things, 2 expressions, that means that you're multiplying. So this is saying 3a times 2a times negative 2a. All right, a positive times a positive is a positive, times a negative is a negative. All right, so that's our final answer is negative. Then we do all our numbers. 3 times 2 is 6, times another 2 is 12. And we have 3 a's that we're multiplying together. Do we agree that that's a to the 3? Okay, good. Next one was another multiplication question. 7 times 3 is 21. A times a squared, that's 3a altogether, that's a to the 3. Then you have two x's and another x, that's x to the 3. Right, 16.5, nearly there. Here, this is a BODMAS question, right? There's a minus there. So we can start subtracting, if you even can subtract, right? You need to first simplify that term by timing these two together, there's a dot. And that term by timing them together. Then they are like terms that you can subtract. Okay, so 5 times 3 is 15. We have 2 x's and 3 x's, that's 5 x's altogether, so x to the 5. Minus, so I'm just carrying down that minus from the question. 2 times 3 is 6. And now I have 1x and 4 x's, that is x to the 5. Alright, are these like terms? X to the 5 and x to the 5? Yes. Okay, so now we can say 15 minus 6 is 9, but it has to be 9x to the 5. Okay, the next one, 16.6. That is one that you should have been able to do after yesterday's lesson, where you are squaring the 3, so that's 3 squared, which is 9. Oh, sorry. There we are, 16.6. Sorry about that jump there. All right, 3 squared is 9. And then here, exponent inside the bracket and outside the bracket, we have to times them, right? So we times them, 3 times 2 is 6, so that's where a to the 6 comes from, right? Okay, next one, negative 2 to the power 3. Guys, what is a negative number when you raise it to an odd power, odd exponent? Negative, right? But what is 2 to the 3? 8. Okay? It's fine if you put in a separate step where you actually said negative 2 to the 3. That's what we did in class yesterday. You can definitely do that. There's nothing wrong with that. Okay, but you can't leave your answer like this. You have to work out that 2 to the 3 is 8. Well, I just realized I was supposed to print that page for you guys, and I put it in the different page. All right, so negative 2 cubed is negative 8. So just make sure that your final answer is that. 16.8, so we find c to the 6 and c to the 3. Where do I have more c's? At the top, 3 more. So c to the 3. And then there's also d squared there, but I can't do anything with. Right, so that should be in the answer. Now 16.9, I want to show you guys remember how to work with that. When you're doing any kind of calculation and you have a mixed number, you always have to first write that as an improper fraction. You guys remember that? You haven't done fractions in a long time, hey? So 2.5, you first have to write as 5 over 2. Remember, guys, how do we do that? 2.5. You're going to say 2 times 2. So you times these two together. The whole number and the denominator, you times it. What's 2 times 2? 4. And then you add the number at the top. So 4 times 1 is 5. So you get 5 over 2. Okay? Okay, then we are now dividing by a fraction. And this you also might have forgotten by now. But when you are dividing by a fraction, you have to sub and times. Does that sound familiar? Sub and times. Write it down next to it, please. Maybe you forgot. So instead of dividing by 5 over 2, we are timesing, multiplying by 2 over 5. And then what I also just did, and you will probably also remember this now that I'm mentioning it, instead of just working with 10a, you remember that we used to write it over 1. So we have a fraction times a fraction. All right. So that's what I did there. 10a over 1, I just wrote it as a fraction. And then I cross cancel, guys. 5 goes into itself once and into 10 twice. Right? So that 10 I was able to cancel out and 2 was in. So what do I have at the top? 2a times 2, which is 4a, and at the bottom just a 1. And this is what maths is going to be like from now on, basically, is when you might do something at the beginning of the year, like fractions, for example, and then later on in the year, you need to remember how we work with fractions because now it's coming up in an algebra question. Right? We're going to be doing geometry. Then we're going to be doing equations later. Then we're going to have to put the two together. Okay, so maths is unfortunately not a whole bunch of separate chapters that you can study separately. They do kind of link together. Right, the last one was just that division question. Again, it's fine if you first wrote it as a fraction. It's probably easier that way. So please do that if it helps. Okay, then you can cancel it off like that. Any questions? Okay, guys, I'm nearly done marking your class test. I'm pretty small. They're taking very long. Okay, out of 45 more. I'm still trying to decide how I'm going to deal with the misconceptions because there are a couple of you that are making the same mistake. So we definitely have to come back to it. I don't want to just give you your test back and not actually have a space to look at it properly. So your test is on the 9th of May, which is, what day is that? Is that not this coming Monday, the Monday after? Okay, I think I'm going to put aside next week, Friday, to do the whole hour just algebra revision. So I'll give you back your class test on Tuesday, but then we won't discuss it in detail. And you will wait until today in a week because you're doing your test the next time I see you. I'll do it now later. Just so that we can get through everything. So I'll make you guys a nice detailed list of exactly what you need to study for the test. But then we're going to look at the class test as well. Some of those questions were really complicated. Okay, so it's fine. I mean, that's also why I wanted you to do it so that I could see what the misconceptions are and what you need. So you will get those back on Monday, but then next week, Friday, we're going to go through it in detail. I'll see if I can find some more practice. But guys, that whole worksheet is very good practice, right? We haven't done all of the questions in that worksheet. A whole bunch of those questions are just mixed exercises. So it's a very good idea to keep working through those. Yes, we're not going to do it. Another two guys on a Tuesday. Yeah, so you'll get them on Wednesday. I'm gonna have to try and fit the geometry in. Yeah, it's fine. Don't worry. The timing is my issue. Yeah, we'll get them on Wednesday. Yes. Yeah. Okay, guys, new heading, new chapter. We are done with algebra for now. We are doing some geometry. Not today. Okay. Okay, geometry of two shapes that we need. Identify and classify triangles. Classify triangles, that's the first section that we're doing today. Okay, I'm gonna write a table or draw up a table. And I will give you guys some time to catch up. I know I've obviously already written this. So we'll do that. Then put everyone to, are you all done with the heading name? Geometry of 2D shape. Okay, so that is the section heading. So guys, again, just like when we started, yes? Yeah? Just like when we started doing algebra and practice, everything that we've done so far actually this year, I'm starting from the basics because we all came from different schools, we all had different teachers in grade 7, so some of you might have done this, some of you might not have. All right, so if you've done this already, just be patient. Okay, we all need to do stuff as well. I just need to make sure that everyone's on the same track, at the same point before we move ahead. All right, so when classifying a triangle, so when they actually ask you, they can give you a triangle and say classify this triangle. Okay, that can be the question. You have to mention the sides and the angles. Always. All right, two things that you have to mention. So I'm going to list now what we are going to look out for when we're talking about sides and what we're talking and when we're talking about angles. Okay, so I'm going to put this in a table, guys, but let's just do the first. I don't know if we'll be able to put this in one page. This is the table that we are doing, just to give you an idea of what it's going to look like, so that you can look at your spacing. So you're going to do the sides like this, and then angles, and we have to put them next to each other because these ones, they correlate. Okay, and then we're going to add. So just make sure that you can put all of that in on the one page. All right, are we all clear on that? You can start copying this down. I just want to make sure that everyone knows what's going on. Okay, and while you are, can you guys see that? That's the dark. Let's see if I've switched the light on. Is that better? Okay, I'm going to freeze that. I'll write it on my tablet while you guys are from there. And I think it's good if you can see the whole table while you're copying it down. Okay. Let me know if you can't read that. So the headings are sides and angles. And guys, you don't have to write the word triangle every single time. You can use the triangle symbol. That will save you some time. Just draw a little triangle. Okay, you don't actually have to write triangle a million times. Once I've copied it down, I'm going to put my table on the board. It might be a bit easier to see. Just 1 second. And I've also, instead of the word apple, I don't know if you know this notation, you can use a thing that looks like that. Right? And then you can put a little X or even an X at the bottom. I'm going to put my X at the top, but so instead of apple, you can use this symbol at the same time. That's all written down the sides part. Then I can show you the angle here. Here. Let me know if you want that with the side part. Maybe that thing, but it's the same as this. But the side one is the same feet. The side, yeah. And then that's the same as good. So guys, this is saying 3 equal angles, and then here they just only want 1 angle, so that's why there's no X there. You can use that notation. In case exams we accepted in the first final class, you are more than welcome to use that symbol instead of writing the word angle. Okay, guys, do we know anything about the 3 angles of a triangle? And what they must be equal to? Yes. 180 degrees. All right, we are going to write that down now. We need to know that in order to answer classification questions. So sometimes they'll only give us 2 angles and then we must calculate the third one. Okay, so the 3 angles in a triangle always have to add up to 180 degrees. So we're going to write that down, okay? Are we done here? Not yet? The line so. Hold on. Thank you for answering. Hold on now. And it's calculating. Okay, guys, now underneath the table, we're just going to write a little bit of information. Okay, so the first one is the 3 angles of the triangle added to 180. So that's the first one that we're going to write down. I'm going to go. Thank you. All right, so there's the three angles of the triangle at 180 degrees, and I would like to please to highlight that. That is very important, guys. In geometry, in all grades going forward, we are always going to use this. All right, whenever you see a triangle, you can use the fact that the three angles add up to 180 degrees. We are going to do examples so that you can see how we're going to use it. All right, but that is a fact. It is a rule. We are always going to use it. The three angles of a triangle add up to 180 degrees. Then I just want us to quickly write down what is an acute angle and an obtuse angle and a right angle. Okay, because in this table, we have now referred to these types of angles, but we might actually know what those angles are. Does anyone know what an acute angle is, please? Good. It's an angle that's less than 90, smaller than 90 degrees. Okay, so acute angle, smaller than 90 degrees. Yeah. You can have 70 and 70 and 40. That is three angles that add up to that. Okay, obtuse angle, what's that? Yes. Bigger than 90. I'm going to put another limit on it though. It's between 90 and 180. Okay, you might not know that section. All right, but obtuse angle is between 90 degrees and 180 degrees. And then a right angle, okay, a 90-degree angle. Okay, so right angle is 90 degrees on the dot. Okay, so those are just the names of those angles that we need to know. I'm going to highlight these terms as well. So guys, if you see anything in the textbook or in the notes that is making reference to any of these terms, we have written them down. Okay, if you forget, you can just look back at this. Okay, we're going to do some examples quickly of where we are actually classifying triangles. All right, so please write examples, and we're going to draw some triangles. Sorry, we're doing a lot of writing today. No, it's straight in the automatically, it's not me. Back to you. In a test, it's good if you draw diagrams in pencil so that you can erase it. But in your own book, you can decide. Okay, so that is the first one. Then you know if you can't make out what those degrees are, those angles. Bottom 127, then we have a 45 at the top there, and the 108. That's angle A. $27 or 45. So guys, like I said, right at the top, we have to classify any triangle that they ask us to based on size and angle. Now, if we're looking at this triangle, does it look like it's actually given us any information about the sides? They didn't give us any side lengths. How else can they give us information about sides? What do they sometimes use? Yeah. Yes, sometimes they use like a line. So say, for example, don't pull this in out because it's not given, I'm going to erase it. Say they do this, right? Then if they put in the same number of lines on different sides, that means that both sides are equal. Okay, but they didn't do that in this case. So they actually haven't given us any information about the sides. But let's look back at the table that we just wrote down, guys. Next to where we wrote down the things about the sides, we wrote down about the angles as well. So these ones go hand in hand, guys. If you have 3 equal sides in a triangle, you will also have 3 equal angles, always, right? If you have 2 equal sides, you will also always have 2 equal angles. If you have no equal sides, you will also have no equal angles. So guys, even if they haven't given you information about the sides, you can figure out something about the sides by looking at the angle. What did they give us? Did we have 3 equal angles or 2 equal angles or no equal angles? No equal angles. That means that we will also have, even though they didn't tell us that, but we will also have no equal sides. All right, so guys, actually, if they've only given us angles, we can do a full classification. All right, but we are going to have to mention 2 things. So I'm going to write underneath here, triangle ABC. Sorry, let me just make this again. So we need to try and write this out properly, guys. I want you to name the triangle. So you're going to write it like that. Triangle ABC. Usually also we write the letters in alphabetical order, but it doesn't really matter. Is now you can decide which order you want to put them in. I usually say either scalene or isosceles or equilateral first. And then I say the what angle thing. Okay, so what did we say? We have 3 or we have no equal angles. So that's going to be scalene. Okay, so I'm going to write scalene. How did I know that? I'm actually going to write it in brackets. You don't really have to, but just because it's the first example, let's do that. No equal angles. Right, that's what we're saying, that it's the same mean triangle. But we also have to say whether it's acute angled, obtuse angled, or right angled. Okay. Now, what types of angles do we have here, guys? That is an acute angle. That is an acute angle, right? Both of these are smaller than 90. You can add that in if you want to. Let's make little arrows. This one is acute. This one is also acute. We've got it smaller than 90, so those are acute angles. But what about 108? That's obtuse, right? 108 is definitely bigger than 90. So what did we say in our table? If you have one obtuse angle, it is called it, right? It's still bigger than 90. No, still then it's smaller than 90. Yes? Obtuse angle, yes. The scalene, obtuse, angle. Sorry that I'm breaking it up, but I'm trying to put it all underneath this picture. So triangle ABC is a scalene, obtuse angle triangle. Yeah, and the reason for that is kind of here at the top in the labeled angle. So I'm not going to put that in brackets as well. It has one obtuse angle. 2 marks for that, guys. 1 mark for scalene, 1 mark for obtuse angle. All right. So what? So they're saying that it's scalene is talking about the side. Yeah. Yeah, we're gonna do another one quickly. Yeah. Yeah. Okay, number 2. Are we all done copying this down? Guys, I want to move away from this picture now. All right. Okay, what is the name of this triangle now, guys? So not the type, the name of the triangle. The previous one was ABC. This is D. Okay. So here they've only given us 2 angles. In the previous question they gave us all 3, but no information about the sides. Again, they haven't given us any information about the sides, right? Now guys, this is now an example where we actually going to have to calculate angle D. What do we know about the 3 angles in a triangle? They add up to 180. All right, so if we want to calculate angle D, what I'm going to do is I'm going to say 180 minus the angles that I already have. Okay, so let's do that. We're going to say angle D is equal to 180 degrees minus 42 minus 42. Guys, this is something new. I don't know if you would have done this in primary school, but whenever we're working with like geometrical rules, all right? So the rules of a triangle, for example, we have to write a reason. And we are going to practice that a lot, but you have to put in brackets the reason, and there's a whole list of reasons according to the CAPS document that you have to use, which we will also give you. The reason is angle sum in triangle. So you actually have to memorize that, guys. Every time you do this 180 minus thing, you have to write that. Okay, it's a bit of a pain, but please, we need to try and remember that. I'm actually going to highlight that reason. That is important, guys. If that reason is not there, you're going to move it off. Actually give a mark for that reason. Okay, so whenever you're doing a 180 minus, also put a tick there above that, but you remember that is worth a mark, please. Angle. Okay, so now you work that out. The answer there is 96. So please fill that in on your picture. In your diagram. That's also something that we need to start doing whenever we're doing calculations for geometry. Pull whatever you've calculated in on your diagram. Right, so D is 96. Now we can see, guys, we have 2 equal angles. 2 equal angles, yes? 42 and 42. So what does that mean? Isosceles. So therefore, triangle DEF is an isosceles. Please try and spell it correctly. You won't do them all, but no, I need to try. That's why it's isosceles, because we have 2 equal angles. Okay, so that's speaking about the sides. They didn't give us information about the sides, right? We've learned that if we have all 3 angles, we can still say whether it's going to be isosceles or scalene or equilateral. Okay, what else? Guys, we need to also still say acute or obtuse or right angle. Stop getting confused. That is an acute angle. 42, acute, 196. Obtuse. So let's just label that one. And we've learned that if you have one obtuse angle in the triangle, we call it an obtuse angle. And guys, this question would be out of 4 marks. You would get a mark for the line here for showing that you're minusing, including your reason. A mark for that angle. And then you would get a mark for isosceles and a mark for obtuse angle. So guys, in a test out of 50, that's 8%. 4 marks is 8%. And that's not really difficult. You just need to memorize that stuff. Okay. All right, I'm going to ask you just to do 2 questions on your own at home over the weekend. So just make sure that everyone's done copying that down. It's from the textbook actually, 4K. Yeah. So like, yes, and big word from the textbook. Okay, exercise 11.1. Okay, number 1, B and F. Yes, it's in a platinum textbook, guys. Yeah. So just to try to classify what all you need to do, you're gonna have to do that at home because it is time to go. Thank you. Thank you, grade 8. Have a lovely long weekend.